Okay. Hello, everybody. My name is Ali Muhammad Ali, and today I'll be talking about 5 different types of reactions. Firstly, to recap, to discuss the difference between physical and chemical changes. Physical change is when a substance is changed without changing the form of the substance. Uh, molecular form of the substance, such as changing the state or just changing the shape of it. For example, ice melting, or water condensing, or water freezing. Uh, or any other physical change, such as a plate breaking, for example. A chemical change is when the molecular structure of the substance is changed. Uh, it's also known as a chemical reaction. For example, wood burning, food cooking, and iron rusting. Generally speaking, a physical change can be, in theory, reversed, while chemical changes cannot without another chemical reaction. So here's an examples of physical changes and chemical changes. Okay, so there is an whenever we complete a chemical reaction, we need to look for evidence of the chemical reaction, or it might just be a chemical change, a physical change. So here the common chemical reaction evidence. A gas is produced, or you see bubbles. A precipitate is formed, which is basically a solid at the end of the solution. Example, if you mix two solutions together, a permanent color change is observed. An energy change occurs. So you see light, heat, or other energy sources. Also, another evidence of chemical reaction is odor is produced. Okay, so the 5 types of chemical reactions. We have synthesis, decomposition, single replacement reaction, double replacement, and combustion. And we'll discuss each one in detail right now. Okay, so first of all, synthesis reaction. Two pure substances combine to form a single substance. Not two or more pure substances. But the most important thing about the synthesis reaction is there's always one product. Okay, so here's the general structure. A plus B equals AB, or it could be even be A plus B plus C equals ABC, or so on. But there's always one product. Here's an example. 3 hydrogen, hydrogen is diatomic, plus 2 nitrogen form ammonia. 2 ammonia because both are diatomic gases. Okay, another second type of reaction is decomposition. This is the reverse of synthesis. It's a single compound, and it can be produced into two or more products. So any number of products, but it must be one single reactant. Okay, for example, so here's the general structure: A plus B, AB equals A plus B. So here's an example: calcium carbonate, carbonate 3, no, actually, sorry, this is carbonate, equals carbonate oxygen plus carbon dioxide. It doesn't matter how it reacts within, but in the end, we have two or more products and one single reactant. Okay, next, we have combustion. Combustion is one of the most common reactions we observe in nature and around us in our daily lives. It is more commonly known as burning. Uh, the general formula for combustion is when you have heat, when substance combines with oxygen, produces heat and carbon dioxide and water. A combustion reaction can have either carbon dioxide or water, but either must be there. Okay, this is what differentiates it from a synthesis reaction. And most of the time you'll find both. Okay, so here's an example. Methane is combined with two oxygen diatomic atoms, and you produce one carbon dioxide and two water molecules. Okay, single replacement reaction. Okay, so a single replacement reaction is when you have a compound and an element replaces one element in that compound. Usually, it's an ionic compound, so a metal replaces a metal, but it can also be a non-metal replaces a non-metal within the ionic compound. It can also work with covalent compounds, uh, but the general formula is AB plus C equals AC plus B. So for this reaction to occur, however, the reacting compound element must be more reactive than the original element to replace it. And we won't get into detail as much into this video, as this is a more general reaction video. But there is very soon another video coming very soon discussing single replacement reactions and double replacement reactions and explaining all the aspects of them. Subscribe so you can never miss them out. Okay, but all you need to know for now is that the element replaces it depending on reactivity series chart. There's no exact pattern for it, but scientists have observed general reactions in natures, and there is a chart to memorize which elements will replace which in this reaction. And here's an acronym to memorize it, but we'll discuss this more in the upcoming video. Okay, so these are what replaces the metals in a metal ionic compound. This is what replaces the non-metals in an ionic compound or a or a covalent compound. Sorry. Okay, so here's two examples where we replace the non-metal. So we can see that selenium chloride plus oxygen replaces the chloride. So we have selenium. No, sorry, it's not selenium. And oxide plus 3 chloride. And the other one is where we replace the metal, where lead replaces the iron because lead is more reactive. Okay, and finally we have double displacement. Double displacement reaction is also a more complicated reaction because it only occurs when two liquids or aqueous solutions, ionic aqueous solutions, are combined together to exchange one element with the other. The general structure, which you need to know for this video, which all you need to understand for this video, is AB plus CD equals AD plus BC. Basically, each compound exchanges one element with the other. Again, upcoming video discussing both this and single displacement. So please subscribe so you don't miss out. Okay, and here's an example of it. Rubidium uh, nitrate plus uh, beryllium fluoride equals beryllium nitride. No, sorry, nitrate plus rubidium fluoride. Okay, so let's practice some questions to see if you understood which type of reaction. Feel free to pause and answer each question with me. Okay. So firstly, we have carbon hydride plus iron equals iron with carbon and hydrogen in an ionic in a in a covalent compound combining all together. So take a moment to pause and guess what this is. Okay, so as you can see, there is multiple reactants and one product. So I'm going to assume that this is synthesis reaction. Okay, so on to the next question. We have two potassium reacting with two water equals two potassium sorry, hydroxide plus hydrogen. Okay, so I can assume that since one element is left out, that this is a single replacement reaction because the hydrogen is left out. Okay, single. Okay, so next we have two NO2, uh, two nitrogen oxide splits into two oxygen diatomic plus two nitrogen diatomic. So since we have one reactant and two products, I'm going to assume that this is decomposition. All right, number 4. We have polyatomic ion reacting with 4 oxygen diatomic, and we have carbon dioxide plus water. Since the reactants are water and carbon dioxide, I'm going to assume that this is combustion. All right, on to the final question. We have 2 magnesium iodide plus a polyatomic ion equals magnesium polyatomic ion plus another one. So we can see that that the elements replaced with each other when magnesium is at first with the iodide, in the end, the Mn is with the iodide, so I'm going to assume that this is a double replacement. All right, so that's all practice questions. Thank you very much for watching, and I'll see you inshallah in the next video. Goodbye.